In this video, I'll be going over the solution to the 2016 AIME 1 problem 13. So in this problem, we have a frog searching for a river, and the river is located on a horizontal line, which is y equals 24. So let's label that as the river. And then there's also a fence, which is located at the horizontal line, y equals 0. And then we have a frog, which is at the point 0, 21. And he can hop in either one of the four directions, unless he gets to the origin. Because if he gets to the origin, then he's not going to hop over. He's only going to move left, right, or up. He's not going to move down and cross the fence. So that's basically what this part is saying. He never chooses a direction that would have him cross the fence, and he starts at the point 0, 21, and he stops when he reaches the point 0, 24. And so we're asked to find the expected number of jumps it'll take him to reach the river. Okay. So first thing that we can see is that he has a 1/2 probability of just not changing his y-coordinate and staying exactly where he is, right? Because if he moves left or right, that's basically like, it doesn't really matter if he moves left or right. We can call moving on an x-coordinate the same as staying where he is. So x-coordinate move equals stay. Okay, and then he can either move up or down with probability of 1/4 per, right? He has a 1/2 probability of staying where he is, and he has a 1/4 probability of moving up or down. Okay, so you may have seen this in a lot of solutions already. Right? We can call e of n, let e of n be the expected number of jumps. It'll be the expected number of jumps at the y-coordinate n. So what we want to find is e of 21. This is our answer. E of 21 equals answer, right? So what we really want to do is come up with a recursive equation for e of n, and then we know we need to find like one or two values, and then we can use our recursive equation to work back down to e of 21, or work up to e of 21, whatever, right? And so one thing that we can notice is, if Freddy is at the point 24, then e of 24 is going to be 0, because he doesn't have to go anywhere. He's already at the river. So we know e of 24 equals 0, right? And now, so for our recursive equation, basically, what we want to do is generalize for any n, what is his expected number of jumps going to be? And we can generalize that by saying, like write it in terms of the expected number of jumps at one below, one above, and where he is. And we can do that by saying, e of n, right? There is a 1/2 probability he stays where he is. And in this 1/2 probability, if he stays where he is, then he's just going to have e of n plus 1 jumps again. Because if he stays where he is and moves, let's say, left, he just added a jump. So that's where this 1 comes from. And his y-coordinate hasn't changed. It stayed the same. So we still have e of n here. So, and there's a 1/2 probability that happens. And so expected value, by the way, is just like the probability times the value that something's going to happen, right? And that's what this problem is asking us for. So probability times the value, which is this. And then there is a 1/4 probability that he moves up. So what happens if he moves up? Well, if he moves up, then his y-coordinate changes to e of n plus 1. But he also jumped 1, so we add an extra jump. So e of n plus 1 plus 1. And same thing if he moved down. If he moves down, he's still jumping. He still has one extra jump. And his expected number of jumps is e of n minus 1 plus 1. Okay, so this is our recursive equation. The thing to note here is that this is only true if n is greater than 1, greater than or equal to 1, but less than 23. Because for 24, it's going to be 0 regardless, because there's no such thing as e of 25. And for 0, he can't go over the fence, and we would also have an e of negative 1 here, which we don't want to deal with. So we already calculated one of the special cases, which is e of 24. So let's try to find the other special case, which is e of 0. So we need to find e of 0. And finding e of 0 might give us some clues as to like what we can do to work our way up to 21, right? So e of 0. He can choose to move in 3 directions. He can either move left, right, or up. He can move left or right with a probability of 1/2. So there's a 1/2 chance, 2/3, because he can move in 3 directions, so 2/3. And if he stays where he is, then that's just going to be e of 0 plus 1. 2/3 e of 0 plus 1, because he had an extra jump moving left or right, and his y-coordinate hasn't changed. And then there's a 1/3 chance that he moves up, and if he moves up, then he's going to jump again, and his expected value moves to 1, because he went up by 1 y-coordinate, okay? So this is our equation for e of 0. So let's solve for e of 0 now. Oops. So multiply everything by 3 to get 3 e of 0 equals 2 e of 0 plus 2 plus e of 1 plus 1. Move the e of 0 over to get e of 0 equals e of 1 plus 3. E of 1 plus 3. Okay, so that's our first value. And so let's try to work iteratively up now, right? So let's use our recursive equation to maybe come up with the value for e of 2. And then let's look at, e of 1, sorry. And let's see if we can find a pattern between e of 0 and e of 1. And then maybe make a generalization to find e of 21. So let's see, e of 1 equals 1/2 times e of 1 plus 1. This is our original recursive equation, plus 1/4 times e of 2 plus 1, plus 1/4 times e of 0 plus 1, but we already know that e of 0 is this, so we just plug that in. So 1/4 times e of 0 plus 1, which is e of 1 plus 4. E of 1 plus 4. Cool. And now we're going to multiply everything by 4 to get 4 e of 1. Let me zoom in a bit. 4 e of 1 equals 2 e of 1 plus 2. Oh, sorry. Plus e of 2 plus 1 plus e of 1 plus 4. Okay. And so now let's move our e of 1s over. And so we got e of 1 equals e of 2 plus 4 plus 2 plus 1, which is 7. E of 2 plus 7. Okay, so we have our 2 base cases for the recursion. So is there a pattern we can see here? So we have a 3 and we have a 7. So what we essentially did is we just added 4. We added 4 to this value, and then we added 1 to our y-coordinates here. So we can say that we can make a generalization here. We can say that E of n equals E of n plus 1, right? And then we can say plus 3 plus 4n. This is our generalization for the recursion, right? Okay. So E of n equals E of n plus 1 plus 3 plus 4n. And for the sake of time, we don't really want to check this for every value, but it works for 0 and 1, so assume it works for everything else. And so now, instead of working up with this, what if we jump to E of 23 and then we work back down? So what is E of 23 going to be? E of 23 is going to be E of 24, which is 0. 0 plus 3 plus 23 times 4, which is 90. Oh, sorry, I forgot the. Oh, yeah, 23 times 4 plus 3, and that gives us 95. Okay, and now we can use that to calculate E of 22, and then we can just work down to E of 21. So we're super close. We almost have our answer. So E of 22 is equal to E of 23, which is 95, plus 3 plus 22 times 4, and that equals 186. And then finally, our final answer, which is the expected value of y coordinate of 21, equals E of 22, which is 186, plus 21 times 4, 21 times 4, plus 3, and that gives us our final answer of 273. So 273 is our answer. And so what we basically did here is we first identified the two outlier cases, the two special cases, which were E of 0 and E of 24. Then we came up with a recursive equation. And then we used E of 0 to work up to E of 1. We found a recursive pattern, and then we shot back up to E of 23, and we worked our way back down to E of 21. And that's how we got our answer of 273. So I hope you found this video helpful. Thank you for watching.